on a journey of exploration into fascinating realm of intellectual property within the context of innovation. It is with great honor and anticipation that we welcome Dr. Ravindra Sundarajan, the lead for global partnership at London South Bank University, as our guide and lecturer on this remarkable subject. With deep gratitude and immense excitement, we are glad for Dr. Ravindra Sundarajan to share his wisdom and experience. I request Dr. S. Magesh Kumar, Professor and Head, Department of Big Data and Network Security, to give the welcome address.
Good afternoon, all. Have a great day. On behalf of our management, Samhita School of Engineering, Institute of CSE, Big Data and Network Security, I feel it is very great pleasure to welcome you all for the one-day seminar on identifying intellectual property component at the early stage of innovation. First of all, let me extend a very warm welcome to our guest speaker, Dr. Ravindra Sundarajan, lead for global partnership, London South Bank University, London. Okay. I also heartily welcome our faculties and students of SSE. Today you have a wonderful day, and you are going to have an innovative seminar on identifying intellectual property component at the early stage of innovation. As we all may know that intellectual property, that is IP, act as key in facilitating the process of taking innovative technology to the market. Sir, will give you a brief about the topic in an interactive manner. Make use of it. Thank you.
I request Dr. M. Mahesh Kumar sir to felicitate the esteemed guest. Thank you, sir. Ravindra Sundarajan has 20 years of academic experience and 10 years in industry. He is currently a School of Engineering lead for Global Partnership at London South Bank University. His expertise lies in applied engineering, particularly in thermofluids and mechanical engineering. He is a senior fellow in Higher Education Academy and a chartered engineer through IMechE. He has extensive experience in renewable energy and hydrogen production and works closely with Renewable Energy Institute. His skills include waste heat recovery, low carbon energy management, and hydrogen production. He is proficient in leading renewable hydrogen teams, business developments, and commercial analysis. He is also served as a technical director of Ventec Engineering Solutions Private Limited, specializing in various pipework systems and energy auditing. He is involved in blue-green hydrogen production and works as a design consultant for green energy projects in India. Let the seminar commence, and may our quest for knowledge and innovation be fruitful and enlightening for all.
Thank you for the introduction. Thank you, Dr. Mahesh. Thank you. Thank you for your patience for waiting so long to hear my talk. Yeah, not talk, just an interactive session. So just to have some interactive session about identifying intellectual property, the early stage. So that's what the topic I'm going to talk about. And also I'm going to take you to the regular production system, what I'm specialized in, and how do you open your thought in this area to excel in an IT sector. What is an opportunity for graduates like you, IT graduates like you in this particular sector. But India is going towards opening up door for green energy. Have you heard about it? No, not in paper, news, everything. India is going to become a pioneer for green energy applications. So that's what I chose my topic to link with where you can stand on as a graduate after graduating. What's your vision in terms of putting yourself into the green energy application? So that's the whole scenario for this presentation. Okay, so before we get into that particular topic, So first let me introduce myself. So I think by looking at your face, everyone quiet and no, don't be shy about everything. You have to be top in all those things. No? So any questions in between, you can feel free to ask. Don't keep quiet all the time. So I must see the interactive session. That's what I would like to do that. Okay, just to give you some thought about myself. When I start my graduation, like you, when I was like you, I'm same like you. Very quiet. I don't speak with everyone. And those days in 90s, we don't have that much facility in India. I'm glad to say that after seeing your facility here, you are in a good hands and you have very good facility and also very good faculties around you to support you, to guide you, to bring you into the industrial standard. So I'm glad to say that, seeing that the technology changes year on year, right? Everything changes. But in 90 those days, we don't have that much things. But having said that, the skill and knowledge from India, people from India can prove anything across the world. That's the thing. If you see in IT sector, everyone in IT sector, so most of the people working in IT across the globe and rule the world. So that's one thing. Just want to, you all know that that's a universal truth. But apart from IT, any other sectors, if you look at people working across the globe and everything, Indians are doing very good. Actually, that's my personal experience. Those days, I'm also like you, very shy and not speaking other people. When I first started going to abroad to start my career as a teacher, lecturer in Malaysia, so I was looking at, I was very quiet and shy. So how do I start my career in another country? So I worked in India, Chennai for about 4 or 5 years, then immediately moved to Malaysia, started in front of me, like these students, that 10, 20 students, although we got expertise in subject, talking is really important. Communicating the knowledge what you need to communicate to the students. So I was very scared. I opened up my discussion, started talking, then I need to realize myself, India provided me that skill. So lots of skill hidden with me. So why can't we expose? When we talk to the people across the world, we can understand that we are very proud of saying that as an Indian, going and doing something in abroad and other countries. Then I moved to England. So again, same, looking at different culture, different people, how we can step into this, how we can do something. So as my early career times, so that provided me lots of experience and opportunities. India provided me opportunity where I grow from, my motherland. So then I have to prove that to different part of the world in such a way we have skill. So we need to prove where we come from, where we graduated from, where we learned from. So that time we don't have that much facility. We education system, good infrastructure. So definitely you may get in good level very soon actually. So open up your mind in such a way. Communication, develop your communication, develop your interaction between people. Watch lots of communication activities. Put yourself in a way when you study the core subject, computing, coding, programming, and all those things. So you can develop other skills also balancely, equally, communication, interacting with people. So that two together, you will become a good engineer in the future. So that's what I just want to say that. So I proved it, something like that. Then I developed my skills slowly, started developing my communication. Now in front of you, talking about my experience. So this is what I want you to become in the future. So that will happen one day. Anyway, so just getting to the topic. So now I'm going to say something about IP. So how do you put yourself in a position to become an engineer in applied area? Something like studying something academically, then you want to start an industry, startup in the future. So in my introduction, you may see that I have a company here. So I own a company as well as an academic person running a company, and what are the difficulties and how we can grow up and in terms of proving our applied education into society. So that's what very important. And so just to step into intellectual property, at the early stage of innovation, particularly what are the opportunity in those areas. Before I give the example, let me introduce the basics of intellectual property. You all know about it. Just a quick play in few slides. I put only main 5 different areas you all can focus. I'm not putting up. So programming falls under, there is an overlap between copyright and trademark. Sorry, something mixed with that. So if you can understand if you write a program, you can go with the copyright, the basic fundamental program. Copyright is to begin with. So to register yourself, not to register, but if you go with that and something like the literacy you are developing, you can register as a copyright. That's the first stage to begin with. What's the difference between patent and copyright? What is the requirement for a patent? What is the requirement for a patent? 3 main things included in this. What's the requirement in the patent? Novel, innovative, applied to industrial application. Industrial application automatically comes. Anything you want to develop, definitely end of the day, the industries want to apply that concept and develop something. For example, if you want to develop a robotic program, something different from existing one. You want to develop a machine learning algorithm for an existing setup. So the industries are like to hear from you. So you can develop that program and industries can adopt it. That could be easily interlinked with each other. But the top 2 things, novel and innovative. So these are all the 2 elements you need to focus with. In terms of functionality, functional application, you can focus with it. Already the program system maybe existed. How do you manipulate it in terms of functionality to come up with a novel, new concept, something new from existing one? Then whether the new can be innovative, your theory, scientific theory has to be new, a little bit new, that could be innovative in the next step. So the people, those who assess in the patent industry, those who are assessing your document, they have a tick box, something like that. They need to see whether this can be proved in these 2-3 categories. So industrial application, easy to get, anyone can write anything to apply into industry, slightly modification of the existing one, or something new, easily can manipulate in the industrial concept. But novel and innovative is a tough task for you. For that, what you need? Skill. Lot of skill, applied theoretical knowledge, what you studied from universities, and start from first year, second year, third year, what you are gathering the theoretical application, then you start attached with one particular area to do your project, finally a project. So something when it comes to application, so don't put your mind vision into different areas, machine learning, so something you want to apply in your skill, you attach with that area, and then read more about where you relate your application. For example, as a computer engineer, you're writing coding for machines, so you're collecting data from machines, and you're writing the algorithm for that. You need to know about the machine functionality. So slightly, that's what I'm saying, read beyond your knowledge, beyond your skills. So you got to go into the additional skill, learn something, how the machine works. What's the science behind it? What's the formula related to the production? So these are all the theoretical application. Then put them, integrate your data collection. Why the data looks like this? What variable we are collecting it? So which variable we are looking at? So that variable can be linked with the scientific theory to achieve something new, something innovative. So this is where you need to stand on. So your application, theoretical approach, what you gather from institute, in industry, in university like this, so that will help you to excel something additional learning with other categories like machineries, any other machine language, all those things. So how do we prove your programming skill can support their application? So something new you can support from them. It's something like integrated work, joint work between people within that industry and your skill, come up with a new programming techniques or something new algorithm, you can manipulate it to come up with novel application in your industry. So in your skill set. So that can be innovative, further innovative, something someone has to prove it, develop it, then it has to be industrial applied concept. So that's an area you have to focus with. Then you could some information I given, so I can send the information for you to have a look at it. So what I'm talking now, I'm not going through that point by point what has been written here, giving you some general information. So in summary, patterns can be written based on the functionality of any anything what you are addressing it. Like I said, basically I'm a mechanical engineer, so I can link machines always with the computer codings. So whatever related to machines, industrial applications. So the functionality has to be proven accordingly, and science and application has to be in depth in those elements. And then trademark is just a branding. So you can see that something like branding for anything. Lots of these are all quite easy to understand. Trademark and copyright, all those things. Everyone can follow it. As an engineer, patent is the main important element for you in IP. And then copyright, we mentioned that, and design. So design. How many of you seen now? If you go to something like supermarket somewhere, I'm sure some car industries already put up a stall in supermarket. You can see the 3D camera of a car, new car they're going to release in the market, how it looks like internally. Now, if you want to go and buy a car, what do you want to expect from a car? Any idea? So let's say, for example, you want to buy a car, go to market and buy a particular car. So what do you expect from that? What's your expectation? Safety, good. Well said. Then color. Sorry, future. Anything else?
Capacity.
Okay, performance. Performance is something more technical. So everyone talk about safety, color. So these are all the things comes into mind for majority of the people. If you visualize that, how it looks like before you buy it. For example, if you go to the showroom, seeing all the cars, none of the car you don't like it. You like none of the car. Right? So no car has been attractive for you. Color is not attractive, shape is not attractive. So then, what decision you're going to make it? No, you won't buy it, isn't it? You want to go for another car industry, another car company. So your expectation is not fulfilled. So for that, car companies are now coming up with the strategy called by introducing VR technology. VR technology to put up you can put the goggles with that, where you can see they can change the design. There is a software. These are all the things you can play with. Software application in that area, VR technology, virtual environment. So they can generate, they can create the shape of a car, shape of the existing. They can't change the shape. If they change the shape, so they have to change the machines in the company. But they can change the color. They can change the aesthetic applications of the car, user-friendly application. So they can see, they can put a different color, mixture of colors, internal seating, layout. They can slightly change it. They can show it to you visually. Do you like it? They put the price tag for everything. If basic model, if they introduce this, the price will go up slightly. If you agree with the price, you like it, by visualizing it, then you can place the order with them. That's what we wanted. That kind of facility you wanted. Technology supports that. So that's the thing called design pattern. So they can create the aesthetic nature of the vehicle or anything, whatever they produce it based on the customer application, customer requirement. They can design it, they can show it. Who supports them? People like you, computing, coding. So main thing, programming, writing programming for that, and working with the industries, and you provide your knowledge to bring that visualization in front of the customer. So they use the machines to bring it as a digital display like this. So this is the area, these are all the areas. So for that, so if people have to develop the coding, something that already existed, what I'm saying, these are all the applications existed. So you can find a small breakthrough in it, come up with a new idea, novelty, then go for a pattern. So these are all the things. Existing one, see the opportunity where opportunity lies, and come up with an idea based on the science you learn and create the introduction for IP. So this is the place where you stand for in early stage, and then if it doesn't work out, think about slightly how to modify this and that, then you can clearly come up the way to crack on in terms of novelty and innovation. So think about that. That's an interesting thing for IP. Then how this has been applied in sustainable, so many funding opportunities and also lots of industries, attracting industries from overseas and also local industry promoting it to come up with an idea of how we can reduce the carbon emission. So that's the thing, that's one of the criteria for every country going forward. How many of you know about clean energy? Clean energy. So we have seen, so energy in the sense, what triggers in your mind? What is energy? Energy. What is energy? The energy, power, something like power, right? Power is the energy. Since you have an IT background, so something general topic about energy. Power, we talk about power, electricity is also one of the energy. Electricity, how it is produced. When you produce electricity, there are lots of byproduct will come. Byproduct, have you seen the industry, power plant producing electricity, nuclear industry, we have 40 minutes from OMR, you can reach nuclear industry. What they do, they are producing electrical energy. Electrical energy by using some technology, I'm not going deep into it. They are producing electrical energy. Coal, Navy, they are producing electrical energy. So electrical energy, without electrical energy, we can't survive. We need energy. When they produce electrical energy, there are many ways to produce electrical energy. So tidal energy and solar energy, wind energy. These are all the application how they produce electrical energy. So in that, while producing that, they release lots of carbon dioxide. Carbon monoxide cannot be carbon dioxide, which is the greatest amount of substance in the air. So carbon dioxide in the air pollute the atmosphere. So completely, we call that as a greenhouse gas emission. So every country is now going towards reducing this CO2 emission, reducing the CO2 emission. India also signed the agreement, which is very important. Paris Agreement, a couple of years ago, every country sit together at the table. In 10 years' time, we can reduce the temperature, in the temperature in the Earth atmosphere, 1.5 degrees. But it is impossible. At the moment, maybe 2.8, 2.9, 3 degrees rising every year. So they want to keep it as a target to minimize it to 1.5. What is an impact for global warming? Any idea why they are talking about this global warming? What is an impact? What it produces? Huh? It was harm to environment in the sense it produces so huge heat in the atmosphere increases up to certain height. We are talking about that height is huge, not near to. Sorry? Damage to what? Come to the point. Damage to what? That's one thing. Ozone damages is something different between gas going and damaging all those. But effect of heat, melting something, isn't it?
Icebergs.
Trouble. So the water comes from the sea, occupies the land slowly. So that's an effect. That's a huge effect. To avoid that, to safeguard the earth, so we have to decrease the amount of heat released from industry. So amount of heat, why this heat is staying in this place? Because of the greenhouse gas emission. Carbon dioxide covers the earth atmosphere. It doesn't allow the heat to radiate or goes outside the layer of gas. So the culprit is CO2. Carbon dioxide emission. If people release lots of carbon dioxide from industry, smoke, everything comes in, that covers as a layer. It doesn't let the heat to go out, heat to spread out. The heats are inside the layer. That layer is huge in height, so we don't want to go that detail in it. That's an application. So what makes us to what thinking can reduce this? Atmospheric carbon dioxide reduction, green energy. Only thing is industrial side energy, green energy, produce green energy rather than using the normal conventional way of producing electricity and all those things. So then the solar, wind all came in. So solar, wind, okay, they produce energy. Will it be supporting? No, if you see that, how much energy worldwide produced. So renewable energy, main renewable energy, these are all the energy. Energy comes from hydropower dam and turbine. Have you seen that in the majority of part of the hill station? So that's hydropower station. And very small portion comes from wind. The data collected in 2023, global energy comes from and solar and other renewables like geothermal and few other renewables. So these are all the energy, very small portion comes from that. But look at, see that. So these are the data given. Sorry. Yeah, I think I focus on the renewable. Okay. If you look at this particular slide, can you see one in green? Oil and gas. Oil and gas industry also producing power. The green one, oil produces their power. So that's a huge amount of power supplied to the world by using oil. So oil releases carbon dioxide, huge quantity of carbon dioxide. So they can't replace it. They are slowly replacing with the green energy, but the world need is huge. So the huge need cannot be addressed very quickly. Still, carbon emission is huge. So that's one thing. Energy goes directly to you as a customer. You need energy. You need energy for everything. So that's one part. Then talking about industry. Industry need energy, and also industry produce something, releases carbon dioxide again. Okay, so for that case, they started generator, diesel generator, produces a lot of emission. So how to replace this? So for industrial application, that's the place hydrogen comes into picture. Green energy, hydrogen concept, country is moving towards at least. So if the country attached with the producing huge amount of hydrogen, use the hydrogen to produce electricity or run the car. So you all like the car. So without diesel engine, without petrol engine, hydrogen engine car can run in the market. So that means that's a way world is going towards. Okay, so lots of countries are started manufacturing hydrogen. India is also putting so much effort, lot of strategy. Every state is writing up the policy, hydrogen policy for safety, all those things. So now they're ready to go with a huge amount of hydrogen production. So when it starts producing hydrogen, like I said, that you people as a computing engineer start writing something to become a early career IP achievement in this, there are many areas are there. Every area already existed. So much people are involving in that area, writing lots of programming applications and machine learning applications are there. But this area is entirely new for everyone, completely new for all those people. So all even new for countries, and there are lots of opportunity to write programming algorithm to support the people, those who are working in this area. So that's what I need to say that. So many opportunities are here. So hydrogen, that's an application of hydrogen. This particular slide, so it's mainly if you are a mechanical or manufacturing engineer, you may understand that. But just to give you some simple understanding about basics of energy. So which fuel carries most number of energy in 1 kg. 1 kg of fuel carries energy is listed here. Can you see? Petrol, your petrol car, gasoline vehicle carries 12.9 kilowatt. You know kilowatt, isn't it? Watts. You use bulb in your home. So if you replace your electric bulb, how many watts each bulb can use? Any idea? This is basics, isn't it? Do you ever seen the light bulb at home written up something? How many watts usually? 40 watts? 40 watts, your computer uses electricity, so it consumes some energy. So the energy can be measured in watts, 40 watts, 30 watts, 60 watts. That's a unit to measure energy. So 1 kg of fuel carries 12.9 kilowatt energy per kg. Petrol carries 12.9 kilowatt is multiplied by 1000. So each bulb uses 60 watts. Kilowatt means multiplied by 1 kilowatt is 1000 watts. So 60 watts, one bulb. How many bulbs carries 1000 watts? Can you imagine how many bulbs? 60, 1000 divided by 60. So that many bulb can input to 1000 watts. Like that, 1 kg of fuel carries 12.9, petrol carries 12.9 kilowatt, 12,900 watts. But hydrogen, can you see, carries 33.3 kilowatt per kg. So hydrogen is a huge amount of energy carrier. So that means you can reduce, instead of using 1 liter petrol, I can use 1 liter hydrogen can replace 3 liter petrol. 1 liter equivalent hydrogen can replace 3 liter petrol. That means I'm burning a less amount of fuel, no emission from hydrogen, but petrol has got lots of emission. That's a transition. Lots of measurement needs for energy industry. They need lots of measurements. So start from production up until end user, customer. When it goes to customer, so there are many areas. So energy transition. So they need measurements in each and every area. So whenever we talk about measurement, you people stand down in that area. So you are the key people to write the programming for measurement system and algorithm to collect the data, collecting data for variables. What are the variables? That's what I said there. So the language comes from you, but the technology from other engineers. So you have to link with them, interlink with them, learn something slightly about the technology for whom you are writing your skills. You are using your skill, your skill, talking to them and gather some information about the technology and start use your based on your skill, you can help them to write the language for their application. So that's an area you can crack on for new invention, writing up the patent, all those things. So wherever we need measurement, storage need measurement, and production need measurement, distribution system need measurement. So everywhere, wherever we need measurement, flow meters. You all seen the petrol station, fuel station, always. Fuel station got dispenser, so you can put the fuel, something like, that's a normal technology. Hydrogen fuel station, going to come in 3 years' time. So that's our expectation. In 2-3 years' time, India may have, in UK, we have 15 hydrogen fuel stations. 15 stations already existed. America got 100 more stations. So hydrogen cars are coming into the market. Where do they go to fill the tank? They need to go to the petrol station. Similar like this to fill the tank. So that fuel station got lots of measurement instrument, like flow meter, how much gas is flowing into this, because they need to collect the money, how much they are filling in, 1 kg going in, something need to measure 1 kg. So flow meter, so that will need lots of language, application, computer programming, how to send the gas inside the system. So these are all the areas, measurement, wherever measurement is there, so the new programming needed. How to optimize the equipment, lots of programming needed. Okay, so these are the area you can target in. And I just given some insight, energy storage, what are all the areas you people can come in and help other engineers to start writing up the coding, writing up the programming and algorithm to support the hydrogen industry. Okay, so new for everyone and lots of opportunity in those areas. So emission control, energy storage, supply chain, also another important thing. Supply chain, just before I complete my speech, just give you a couple more information about supply chain and fuel cells. What is it? Supply chain, what do you mean by supply chain? Any idea? People are talking about supply chain, what is supply chain? So if somebody producing something, industries are producing laptop. So if the laptop stays in the industry, what profit they are making it. They are producing it, keeping in the industry, not moving to the consumer, not sending to the dealer. So who comes in between? Somebody has to transport this to dealer. Someone has to take it to the dealer, take it to the consumer directly. So the whole value chain, supply chain, it's not only one person's job. So it may be integrated with everywhere. So the supply chain for hydrogen supply chain need programming skills. Programming skills. So they need lots of algorithm. ML is playing the majority of the role. Feedback from supplier, key into the data and coming up with the model. So something which can be new, innovative. So that can be useful for writing up the patent. So these are all the areas got huge opportunity, particularly focusing with one new product which is going to come up in the market in the next 30 years. Next 30 years. So lots of existing one, lot of people working in it. Where is new coming in? So that's an area you need to look into it, target it, and also I said that the new product which is coming up to the market is more benefit to the environment. So environment benefit. That means you are doing something, end of the day, everyone need money to work and sustain. So getting money for doing something good for those who are, after 20, 30 years, we need to the world as a clean world, and for them to come and, something, do some lots of inventions. So when we attach in those areas and helping other people, that's a good cause of doing some good work, and the skills are utilized in a proper way, something like, helping each and every one. Okay, fuel cells is another application. So there are lots of applications of hydrogen industry where you people can step in. And if you need more information to talk about all these topics, and I will leave my email ID or anything, you talk with your faculty, so we can have an online session or anything in the future. That's also perfectly all right for me. So I hope you got something from me in terms of future field application. So it's the basics. I'll discuss all these things within 1 hour. There are huge area there for a future. Okay. So any questions? Thank you for listening. Any questions? Okay. No worries. If you got question later, you may send me the email. We can talk about it. Yeah. Thank you very much.
Thank you, sir. I request Dr. S. Professor, Department of Big Data and Network Security, to give the word of thanks.
Good afternoon to all. First of all, I would like to express my sincere thanks to our management, Sarkar School of Engineering, CMAX. I am happy to register my sincere thanks to our beloved Director Madam for giving this opportunity to our department to conduct seminar. Next, I would like to thank today's speaker, Mr. Ravindran, Senior Consultant, Lead for Global Partnership, London South Bank University, for making an excellent presentation, making this seminar a very meaningful and interesting, sir. Thank you. Last but not least, I thank our HOD, colleagues, students of SSC. Once again, thank you. Thank you.